All right, we're back. It is COMP125, summer 2016, lesson 12, part 2. We want to do a bit of an intro to TypeScript today, and I want to talk about what this is. So we've got our JavaScript, but I want to make this into TypeScript. How do I do that? Well, we need a bunch of different, we need some setup again, okay? Here's the setup that you need to make this into TypeScript. Number one, change the file. So instead of it saying JS, it says TS. So we're going to right-click, and we're going to rename this file from JS to TS. Okay, that's the first thing. Now it's a TypeScript file. Okay, number one. Two, we need another configuration file to help us out. So in the root of our folder, I'm going to add a new file, and it's going to be called tsconfig.json, a little configuration file. And the little configuration file has to look like this. So I use my opening closing curly braces, and then what I want to do is press Control Space, and it says, hey, here's the stuff that, because Visual Studio Code knows about tsconfig.json, I want something called compiler options. Compiler options. Because I want to compile. TypeScript is a compiled language. We add stuff to TypeScript to make JavaScript easier. But we need to compile it and change it from TypeScript into JavaScript, because browsers don't understand TypeScript. They only understand JavaScript, right? So in our tsconfig.json, we set up some compiler options. Here they are. I'm giving them to you. We want to choose our target. Our target is going to be ES5. ES5 stands for ECMAScript 5, which is the most stable version of JavaScript out there right now, and the one that's most acceptable. ECMAScript 6 or ES2015 is out there. I've talked about it before, but it's not 100% compatible yet in all browsers. So that's the first thing. Then we also want to talk about our module system, because we're going to modularize our stuff, right? Our module should be CommonJS, right? Because that's the normal one that everyone uses right now. Also, System.js is very popular. The last one is going to be source maps. I want to turn source maps on because source maps help us troubleshoot, right? We want to turn source maps on. That's it. Those three things in our compiler. This tells our compiler, as an example, that every time that I compile I transpile from TypeScript to JavaScript, this is my target. Because remember, what happens with TypeScript is this: it takes whatever I type in TypeScript and converts it into JavaScript. The conversion is called emitting. I'm going to emit pure JavaScript from my TypeScript, and this little thing here tells me how I'm going to do it. It tells the compiler how to change things to work perfectly on the browser, right? So I need this one file, tsconfig.json. Hint, hint, it'll be on your test next week, your quiz, right? Next, tsconfig.json. The next thing I need to do is I need to set up a way to compile. And I can do it on the command line if I want to. I could do something like this. So I could go here, and I could say something like this, tsc, and press space, or press enter, like this. What it's going to do, it's going to look at my files and transpile from TypeScript. Look at how it did it, just tsc on the command line, from TypeScript into JavaScript. And if you notice, it's identical right now, because there's no differences. It is JavaScript right now. TypeScript is JavaScript, and then some, and more. And JavaScript works with TypeScript. But I could add stuff to TypeScript to make JavaScript better. And we'll talk about how that works out. So notice I have three files now. I have an app.js, I have an app.ts, and I have an app.js.map, which helps me with code hinting and with troubleshooting. All right. So that's what the tsc command does. tsc, in order for us to use TypeScript, by the way, we have to have our TypeScript installed. So let me do that. Let me put that in there for you. In order for you to use tsc, you have to go npm install TypeScript, right? And then -G for global. You need to do that command, or else you can't do the tsc command. So please do that now. Right now, after you do that, when you install TypeScript, right, for your npm command, you should be able to do I should have a TypeScript version of 1.8.10. Right? And if I look at the TypeScript online, if I look at TypeScript online for a second, here's TypeScript. You can also see that inside here, under the installation procedures, you can see the same thing. Install, npm install -G TypeScript. And then whenever you want to transpile from TypeScript to JavaScript, you need to use the tsc command. But that becomes really rather tedious, right? Because it's a lot of time. I got to go on my compiler, and then just like we used to do Java or C# on the compiler, and we want our IDE or our text editor to do stuff for us a little better. And so instead of doing this, we can have it so that if you press Command-Shift-B on the Mac or Control-Shift-B on Windows systems, it should run a task that does the compilation for you. So let's do that. So I'll say Command-Shift-B, and it says, oh, no task runner configured. And I want to configure a task runner. This is in Visual Studio Code. Under the task runner, I want to choose watch mode. Okay, watch mode. This one. There's two that come up: TypeScript tsconfig.json, and the other one is watch mode. I want to choose watch mode. When I choose watch mode, I get this. It says do the following: compile everything that's in my list, any TS files that I find in my project, and also this W switch. What it does is it watches for any changes. So anytime I change something in my project, it automatically transpiles for me on save. That's what we need to do, folks. If we don't do that, then what ends up happening is we have to do everything manually for every single time, which is to me a pain, right? So this is a really big savior. This is something that they installed lately with Visual Studio Code. Before, you had to use some other kind of task runner like Gulp or Grunt or something like that to do the compilation process automatically for you. So how do I do that? I started off by this task runner by pressing Command-Shift-B, right? And when it does it, you see this little thing that ran in the bottom there for 1 second. It's running now. So now if I change something, so here's my TypeScript file, and here's my JavaScript file. They're identical pretty much. Take a look. Now, they look identical, right? But if I want to change something on this side, for example, I want to say my canvas element, this is TypeScript. I can define my canvas element as a HTML element. I can say, well, you know what, my canvas element is an HTML element, right? I can do that and save. Now, it doesn't do anything, but it transpiles. Notice that it didn't change anything. When I create a type for my canvas, all it does is help me understand what my canvas can do. Same thing with stage. I can say, well, my stage then is also a specific type. It is of type create.js.stage. That's the type. Save. Notice any changes on the right? No. Because types don't mean anything in JavaScript, so when you transpile, you get pure JavaScript again. How about hello label? Hello label is also of a type. Hello label is create.js.text. That's what it is. That's the type of my hello label. When I transpile, I get nothing on the side. But here's what I really do get. Remember I talked about before, if I hover over hello label and see what I got before, I was getting any. Now I'm getting, it's of type create.js.text. And if I hover over the rotation, it tells me exactly what it does. Display object rotation, it returns a number. Okay, I can do the same thing for update. And I can inspect any element that's inside TypeScript now, right, to tell me what it does, right? So this is really good. This is what TypeScript's all about, typing. Here's something else. I can also tell that my function in it, what functions return. What does my function return? Nothing. So it returns void. Again, this is all for type safety, right? Same thing with my game loop. My game loop returns void, and so does my main function. It all returns void, right? Hey, this is cool, but does it change anything on this side? Hell no. It's identical. Why? Because it doesn't mean anything to JavaScript. It's just for us. It's tooling for us to be able to do less errors. You use TypeScript. The number one reason to use TypeScript is reduce errors. Create a type-safe environment. Before, it would just fail silently if you made a mistake, right? Now, no. Once you describe this, and let's say, for example, I'm going to use this example, right? Once I've described that it's got to be an element, right? Notice how my stage, right? It's listening for a canvas element. But what if I put something in there like a number, right? So I change my canvas to 5, right? Well, 5 is an object. That's okay. But what if it's something else? What if I change something that doesn't know about, like nothing? Before, I wouldn't get an error like this. But now it says supply parameters do not match any signature of call target. This is what I'm looking for. I'm looking for an HTML element. I'm looking for a string. I'm looking for an object. Never would get that before. Why? Because JavaScript fails silently. It doesn't tell us anything. If I type in canvas, the error goes away. So it helps us code. TypeScript helps us reduce errors ahead of time. And combined with Visual Studio Code, which is the #1 text editor for now that helps us do that, it's good. Visual Studio is very good as well now with TypeScript and JavaScript, right? But TypeScript is the #1 language that's being used for things like Angular 2, right? That's coming up. And if you want to build large enterprise-level applications with JavaScript, we're starting to use TypeScript more and more, right? Because it helps us build stuff easier. Well, here's how I can really build stuff easier. Remember we did object orientation right before. Well, remember that before I can use classes and objects, right? I can use classes and objects, but I have to define the class. Remember how we did it before? Well, remember also how easy it was to define something on the JavaScript playground or a TypeScript playground where I can define a class and then use the class later on, right? Let's do that now. I'm just going to kind of close this one off so we have a little bit more room. And I want to unsplit. There we go. No, I want to unsplit. There we go. So what I want to do here is inside my TypeScript file, in the top somewhere, I want to define another class. All right? Let's try this out first. We'll do it inside the same file for now. And later on, we'll define it as a separate file. Right? So I want to declare a class. Right? And I want to make my class, I want to call this thing label. Right? My label class, right? Like this. My label class has a constructor. Like normal constructor. There we go. So here's my label class. All right. In my label class, I don't want just to be just an empty class that I just call label. I want it, and here's the beautiful thing, guys and girls, to extend my createjs.text class. So here's where I want to do it. Up here, I want to use the extends keyword. Right? I want it to extend createjs.text. Okay. Automatically, I get some errors. I get these little lines here. It tells me that in order for me to extend the class, I need to pass something into the constructor, right? And my constructor requires something. It requires a super call, right? So I'm going to put the word super in here. Now this is enough if I wanted to do this, remember, because my text doesn't need, it's 3 optional components. The string is optional, my font is optional, and my colors are optional. But I probably want to pass them in there, right? So for example, in my constructor, I want to take in my string, my text string, if you will, or my label string. Let's call it that. So I want to get label string. That's in my constructor, which is of type string, right? Now I'm using typing to help me out, right? And the next piece I want in my constructor is the label font. I'm making this up, which is a string as well. And the last thing I want is my label color, which is the string as well. So those 3 things. I want to get those 3 things. Well, I want to pass label string, label font, and label color into my superclass constructor. So I'm going to do that. Label string, label font, label color. Okay, great. This does everything here so far. So far, I don't understand why this is helping me. What if I know that I'm going to do this all the time, right? Regex and reg-y, all that stuff. And I don't want to do it here. And I also want to take in my x and y coordinates for my label. So I can do that too. I can say, well, I also want my x coordinate, which is a number. And I also want my y coordinate, which is a number. And you know what? I also want to know if this is centered or not. So I can ask that as well. So I'm going to say is centered, which is of type Boolean. Okay, I'm going to put these requirements just in a row so you can see them. Not because they have to be put this way, but because so that you can see them all on one page. All right? So I'm just going to kind of, these are all my constructor function that I'm making right now. So I'm making a class with a bunch of objects that I'm taking into my constructor object. I'll put those 2 in the same line. There we go. All right, so that's my constructor. I'm not passing my x and y coordinates in here. I'm just saying something like this. inside my constructor function, I can say something like this, which points to the label itself, dot x is equal to x, because x, the label, is a text object now, right? And this dot y is equal to y, the y that's coming from my constructor. The x is coming from my constructor. If I hover over the y, it says it's a local parameter. If I hover over the x, it says it's a create.js display object.x coordinate. Those are two different things. You can see, right? This is relating to the label class. If I hover over the this keyword, it tells me what the context is, which is awesome. By the way, no other language does that. Not Java, not C#, not anything else. Only TypeScript. All right. So this x and this y, this and I do that. And also, I want to check to see if is centered is true, right? Then I want to do this stuff. I want to do my regex and regY. I want to center it. Otherwise, I won't. So I want to do something like this. I want to say, well, that's nice, Tom. But how about this? If is centered, I pass that in as an option. I can say, well, then do this dot regex, right, is equal to this dot get measured width, where we did this before, multiplied by 0.5, and this dot regY, if it's centered, right, is equal to this dot get measured height multiplied by 0.5. Only if it's centered. Oof. That's my label class. And my label class allows me to enter stuff in and decide where my label is going to go. Okay? That's all it does for now. I can expand on this label class later on, but this is all inside my constructor. My label class does not have any other methods. By the way, if I want to kind of do any kind of stuff for my label class, right? You can see that it gives me all the comments that I want. This is all in Visual Studio Code, by the way. It's just a little extension that I use in called document this. Okay, document this. All right. So if I go back here and if I see this, I've got my class now. Instead of using my hello label as a create.js text object, let's make it my label. So I'm going to change it up here. So instead of my var as create.js text, I'm going to say label. Right? It's my label class. That's what my hello label is. And if I hover over label, it says it's a class label. That's the type it is. And now it makes more sense. So now, instead of doing all this, right? I don't have to do this anymore. I can just make this a label, and I can put this in there plus the x and y coordinates, which is 160 and 160, and I want to center it, which is true. If I hover over my label, it's not a create.js label. It's just a new label, right? If I hover over it, I get this. I get all the stuff that I need from my class, just like you normally would for any other program, any other kind of language, right? Okay, I just cut down a whole hell of a lot of work for you, right? Because now you know object-oriented programming in JavaScript. You know how to do it way faster than you would normally do it. Now take a look. I've got my class up here, and I'm using it down here. Let's see, first of all, does it even work, right? Nice, Tom. You made it nice. You say it works, but how does it really work? Can you prove it to me? Well, let's try light server and see what happens. Yes, it does. Well, let's take a look at the JavaScript that it emitted, right? What JavaScript did it emit? Well, I can look at that. I can see the JavaScript that it emitted right here. And if I look at the app.js, you can see that this is the JavaScript that it emitted, right? So here is the class that I made. And notice that it uses this funky extends method that I made, right? And what it does is it calls the extends method right here and does the exact same thing that we normally have. We have something called the closure. Here's our closure, right? Another closure within a closure that creates that object. Yes? I can do the same thing in JavaScript, but it's way more difficult to do, especially with this. It actually mimics inheritance, classical inheritance.
Oh, that's what you use.
Yes. So now we can use the same methods in our mind as C# I mean, you just learned, object-oriented programming in C# this semester for some of you, COMP125. Now you can use the same idea that you learned here in JavaScript. And the same thing with Java. If you learn Java next semester, you can use the same kind of stuff. So now I can port my code from one language to the other by using TypeScript. That's another reason to use TypeScript. I want to port my code that's object-oriented from one language. I can use it inside another language with TypeScript, right? This is nice, yes?
All the browsers can exit the TypeScript?
No, remember I have to compile it. I have to transpile it from TypeScript to JavaScript. So now I'm getting the thing that's in my browser is the JavaScript file, right? The JS file, not the TS file. TS file is for us. TS file is our map, is our blueprint. And what happens is the compiler takes the TS file and emits JavaScript. That's what it does.
Our JavaScript file will be blank. How will you create the code?
No, our JavaScript file is not blank. Our JavaScript file is full of this stuff, right? And so what the compiler does, it takes the TypeScript stuff, TypeScript file, and changes it into pure JavaScript.
You don't need to think about the JS file.
It'll be created for us when you transpile. If you follow the video and do what I did. Okay, this is nice. This is really nice, but this is becoming really cluttered. And now I'm going to show you one more thing of TypeScript. I want to stop, right? Because we only have 2 minutes. So in 2 minutes, what I really want to do is this. I want to take my object, which is this label object, and I want to put it in its own file, right? And I want to reference that file inside my file. So I don't have, because so far we've been using all these files, and my JavaScript file is getting bigger and bigger and bigger and really unmanageable. And I'm using a class within a file. I don't want to do that. I want to reference the class from another file. How do I do that? Modules is what we're talking about here. You can do it in JavaScript too, but it's really more challenging to do. So how do I want to do it? I want to make another folder inside my scripts folder. I'm going to call this thing objects. Inside my objects folder, I want to make a new file called label.ts. Here's my label.ts file, right? Now notice that it's going to generate my JavaScript file because I'm in watch mode right now with my task runner, right? So what I want to do is I want to take the stuff that I got in my app.ts file, this class that's in my app.ts file. I want to take it, this whole thing, right? I want to cut it out, right? Notice I'm getting an error right now with label. That's okay. We're going to fix that. I'm going to go to my label.ts file in my objects folder, under my scripts folder, right, and pop it in there. So there it is. So again, nothing in there. Label TS, right? Let's kill these other ones so I don't confuse you for a second. So my label TS is creating my label class. In my app.ts, I've removed my label class, right? But I got to somehow reference this. And the way to do that is to create a namespace. I like to call it a module. You can use the word module. So here's how we do it. Module, objects, we're going to call it the objects module. It's a namespace that's going to contain my class label. It's going to contain my class label. Here it is. So I'm just going to format this thing. My class label is now inside my objects module. That's inside of a objects folder, right? That has its own file called label.ts. All right, don't worry, I'm going to go through this again next week. All right. One thing is I can never see anything in my objects, in my module, because I haven't exposed it. And I'm going to do that by using the export keyword. So now I use the export keyword on my class. I can see it that it's outside my objects, right? But I want to use it inside my app.ts. And there's one more thing I got to do here. In my index.html, I got to include this class, this new object here. So I'm going to take a script file, put it in here. I got to include all my scripts in my index.html as a manifest. That's what I got to see it as. I'm going to right-click on my label.ts and copy it, the path, and replace this one with that. So I'm going to get rid of scripts. And I also got to change the ending. It can't be TS. It's got to be JS because it doesn't understand. TypeScript. And the reason why I'm putting it before my app.js, it has to exist so that my app.js can reference it. So any objects that I want to reference have to be made before in order in my document. Okay, so this is the second step. So 2 steps. One step is I create another file somewhere in another folder in my project. Step 2, I attach it to my index.html. Have to be 100%. Step 3, I need to use typings. And what we're going to do here is inside my app.ts at the top, right? I'm going to use the // way at the top. I'm going to use // notation to say something like this. Reference path. I should probably do it like this. Reference path is equal to, and now where is this thing relative to my app.ts? My app.ts is inside my scripts. That means I have to go into my objects, right? But it has to go, just saying, it has to be under my script objects. If I see this, if I go put in something like objects and then / label.ts, that's the path, right? Because I got to go into my objects folder and look in label.ts to get a reference to my new library I just made. Whew. Now, this isn't label. What is it? Objects.label, because I've put it inside my objects library. So objects.label. And if that's true, once I've done this, then this should also be objects.label. And what I've done in a very short little time is when I transpile, this is what it looks like. Here's my app.js. Notice that it looks the same. I don't have anything in here. I still have my reference path in here, right? And I don't have any typing. I don't have any typing. This is objects label. But it knows where to get it because of this reference. This reference tells the compiler how to block everything together, right? That's what it does. And my label.ts, this is my label.ts. My label.js looks like this, right? It has the objects as an external function. It has my label, which is my class, as an internal closure, and then my constructor as another closure. Whoa, lots of syntax, and I can do it all with beautifully coded constructor methodology that we always know and love, right? Now for the test. Does it work? Because we can do all that stuff, but who cares, right? So we have to go back to my thing and check it out. How do I know that this is actually doing that? It's not. I'm not lying, right? Well, if you go into inspect, and if you look at the sources, if I go to sources now, you can see that under scripts, I have an objects folder with a label.ts file, right? And my app.ts file. This is what it looks like right here. So this is how it's working. So I've actually split up my files, my project, my application now, into separate files, right? And this, my friends, is the way we create enterprise-level applications with JavaScript, one module at a time, right? We've created the label object, and I can reuse this label class over and over again now, anywhere in my application. I don't have to ever code that regex and regY again. I just have to pass in, is it centered or not, right? Just like we would for anything else we use. I'm going to put this on GitHub, and then we'll discuss everything next time. What I'm going to do also is I'm going to get you to do a little lab, and the lab is going to be this. Very simple. I want you to make your own label, right? Your own label using the classes that I'm going to give you. All these files I just made right now, I want you to make your own label, right? And I want you to rotate it the other way, right? Instead of making it rotate 0.5 this way, I want you to think about it. How do I rotate it the other way, right? Minus equals instead of plus equals, right? And I want you to change your script. So instead of it saying hello world, I want you to put your name in there, all right? Put your name in there and make it rotate the other way, left instead of right, right? And that's your lab for 2%, okay? So instead of it rotating this way, change hello world to your name. Huh? Friday. No. It's Friday. Yes. You can use my files. Yes. I'll put it up, and the lab will be listed today. It'll be all the details of the lab will be up on eCentennial. It's very simple. Okay. Yes. Thanks so much. I'll see you guys next week on Monday.
So what is the purpose of the